Day 3, Problem 1. A rectangular wooden gate has a diagonal brace from corner to opposite corner. The brace is 5 feet long and the gate is 3 feet wide. Sketch a diagram. Okay. This is describing a rectangle shape, and so we're going to begin by drawing a rectangle. This is the gate, and we're told that there is a diagonal brace from corner to opposite corner. And it doesn't say from which corner to which corner, so for our sketch I'm going to draw from this corner down to this corner. And as soon as I do that, no doubt you recognize the right triangle that's created within that rectangle. We're told that the brace is 5 feet long, so it's the diagonal segment that is labeled 5 feet. And that the gate is 3 feet wide. So across here, this is the 3 feet. And there is our diagram. Now part B, use the Pythagorean theorem to find the gate's height. A squared plus B squared equals C squared. The letter A is 3. The letter B is the leg of the right triangle that we do not know. And so in the diagram we can label that with the variable b, and in our equation keep using the variable b. Now for the letter C, the hypotenuse of the right triangle, that is the 5. So here's our equation that we're going to solve for the variable b. Now to isolate the b term, we need to remove the 3 squared, which is added to the b term. And we can do that using subtraction. So subtract 3 squared on both sides of the equation. 3 squared subtract 3 squared is 0, and now the b squared is alone. On the right side of the equation, 5 squared is 25, minus 3 squared, which is 9, so 25 minus 9, that makes 16. Now a square root. The square root of b squared and the square root of 16. The square root of b squared is b. And the square root of 16. What number multiplied by itself makes 16? That is 4. And so we have the solution b equals 4. In our drawing, the letter B is written on this side of the right triangle, which is representing the height of the gate. That is what we were asked to figure out, the gate's height, and so we have found our answer is 4 feet. So 4 feet. Now day 3, problem 2. Graph figure ABC that has these 3 vertices. So point A is 2, 0. From the origin, that is right here, point A. Point B, 2, 5, from the origin, over 2, and up 5. Here is point B. And point C, 4, 3, from the origin, over 4, and up 3. Here is point C. So connecting together, we have this triangle. Now in question B, we're going to create the dilation of the triangle using a scale factor of 1.25. So a dilation is a transformation of the triangle, and the transformation that's referred to when you use the word dilation is a size change. We're going to make the triangle larger by multiplying distances by 1.25. So if point A is 2, 0, and we transform point A by multiplying by 1.25, then what will be the coordinates of A prime? Well, 2 times 1.25 we need to figure out. 2 times 1.25 would be like 1.25 plus 1.25. That's 2.5. And then 0 times 1.25 is 0. So point A prime at 2.5, 0 is located right here. A prime. Now point B. Point B is at 2, 5, and we're going to transform point B by multiplying by 1.25. That's going to create B prime. So 2 times 1.25 we did earlier and got 2.5. And then 5 times 1.25. 5 times 1 is 5, and 5 times 0.25 is 1.25. Adding those together, that is 6.25. So here's the origin, over to 2.5, and up to 6.25. That's not halfway up, that'd be 6.5. 6.25 is more like right here. B prime. And now point C. Point C was at 4, 3. And we want to transform it by multiplying by 1.25. And that's going to create C prime. 4 times 1.25. Well, 4 times 1 is 4. And 4 times 0.25 is 1. 4 plus 1 makes 5. Now let's look at the y coordinate. 3 times 1.25. 3 times 1 is 3. And 3 times 0.25 is 0.75. And so that's 3.75. From the origin over to 5, and then up to 3.75. Halfway up is 0.5, so a little bit farther would be the 0.75. Connecting these together, we're going to get our larger triangle. And so in red ink on the grid is the graph of the dilation, and written right in this area are the coordinates of the dilated image.